Hello, my name is Rohit Jatla. I'm from the EC department, KL University. I recently got placed in analog devices with a package of 20.64 lakhs per annum. The courses provided by the EC department, such as digital system design, digital signal processing, communication systems and system designing, and machine learning, were very helpful for me to crack the interview. The department also provides 9 special streams. Few of them are IoT, robotics and automation, PLSI, and many more. Moreover, the department also conducts technical clubs where you can implement the things that you learn in your classes so that you could gain hands-on experience, which in turn gives you a broader perspective of things.
Good afternoon, all. I welcome back all the participants for session 3 of day 4 FDP on integration of renewable energy and smart grids for smart cities. I would like to take the privilege to introduce the speaker for this session, Engineer Sharda Jadon. She has pursued her BTech in the stream of mechanical engineering, and she had done her MBA in business analytics, and she had also finished the courses of design and structural courses from IISc. And she worked with various domains like truck and off-highways, aircrafts, helicopters, industrial production, wind turbine blades as computer-aided engineer expert. Officially, her journey has started in 2011 from L&T Technology Services as computer-aided engineer and assistant manager. She also has served as senior engineer, concrete mixture trucks in Essex. And she also served as senior engineer seatbelt domain in Autoliv. And she's currently now working as product development engineer in LM since 2018 as FEA expert in blade design process. Currently, her responsibilities include product structural design and analysis, certification and blade production support, structure failure mode evaluation, blade test simulation. So apart from her career responsibilities, she also has a very interesting hobbies. Like she is having a hobby of doing a martial arts in Taekwondo. And for this, she also got black belt, second day in Taekwondo, and she also has Six Sigma green belt. She also has won medal in 2018 Malaysia International Taekwondo Championship, and she's a Taekwondo national referee as well as a state Taekwondo coach. So we are really honored to have you for this session, ma'am. Kindly, can I invite you to take over the session?
Sure. Thank you
Please,
so
ma'am.
much for this introduction, and thank you for the KL University for the invitation. Hope you all are good and healthy.
Yes, ma'am.
So,
Yes, ma'am.
yeah, thank you. So, I'll share my presentation. Let me know if you can see my screen. Is my screen visible to all?
Yes, ma'am. Visible.
Perfect. Yeah, thank you. So, why we are here? Like, we all are talking about wind energy. We are talking about green energy, better world. So, there are various ways to make this world better, cleaner. One of them is wind energy. And how we can do this, together we can do this part. So thank you so much for the beautiful introduction. I'll skip that part. Now you can see the population of the world is increasing day by day. As the population increasing, demand of energy also increases. So we have to have some modes where we can continue this supply of the wind, a supply of the energy to the requirements. And only the current requirements, current source of energies, whatever we have, is not sufficient. We have to be more advanced in the selections of new source of energies. Before starting with the session, I will just give you a brief introduction about my organization, LM That is, LM it is a part of GE Renewables, and we are in many part of the world, you can see. And just quick highlights, we have 13 blade factories and 13,000 plus people working with us. And we have till now, from 1978, we have created almost equal to 2.5 lakhs blades. And in last year itself, in 2020, where it was a pandemic, but we delivered around 13,567 blades. So apart from that, how much impact it will making on the carbon reduction and many things. So our journey actually started long back. Uh, we LM started with furnitures, then materials, then yash, and then they come into the business of wind turbines. And many times LM Wind is uh, highlighted as a world #1 wind turbine supplier. Just a quick summary how this started from a furniture, wooden furniture, and they advanced in the technologies, and then now we are the one of the best supplier for the wind. So this is about the business. This is about my organization. Now coming what we are here to discuss with. So first of all, what is a renewable energy actually? Everywhere we are seeing green energy, renewable energy. What exactly renewable energy is? So before that also again a question, general question, from where this energy come from? If I'll say energy come from sun, any kind of energy if you see. So either you have a light source or a heat or light source both. So as you people know that light source will help us to get food for plants and then animal too. And then with the heat and pressure, all those decomposed, all those things will convert into fossil fuels, and which further gave us coal, oil, and natural gases. And there is another way to extract the sun energy, that is what sun is already giving is wind and solar. As we already know, solar is how people are using like anything nowadays, and wind is also accelerating. So above one, we call it as a non-renewable one, which is coal, oil, and natural gases, whereas non-renewable is solar, wind, and hydro, because they will keep on. Non-renewable, it may get extinct after some time, but solar energy, like sun, wind, and hydro, it will keep going on. So we should start extracting, we should think about something which will keep on going and fulfill our energy requirements. This is currently the scenario is how the energy sources and the current and the future, like what people are expecting. So if you can see that how this global annual installed wind capacity increased from 2001 to 2017, and the good news is it will increase further. So you can see here like how generally in 2018 electricity is generated. So 38% is via coal, which actually a problematic thing because it emit lots of carbon dioxide and which ultimately cause in the greenhouse effect. Then there is a gas which 23%, hydro and other 19, and nuclear 10%, solar PVs and wind only 7%. So there's a huge scope to enhance this zone of solar PVs and wind energy. Not just to show you what exactly the wind turbine is look like, just a very small basic thing. It has wind, rotor, pitch system, then generator, controller, yaw drive, and tower. But here, I'll just discuss about one thing, which is contributing 20% of its cost also, and it is most important component in the wind turbine. That is our rotor. So here, the rotor blade, the mission critical component we can say here. And as you know that we are increasing day by day, the size of wind turbine is increasing. Like it was started from just 7.7 meters, then in 1978, and then we increased our size by 23.5 meters. So what exactly the 77 means? That it can give like approximately electricity to 55 houses. And then it increases in 2002, 2004, and 12. And now in 2019, we are having Heliod X, which is 12 megawatt. And the rotor dimension is 220 meters. The blade size is 107 meters. Isn't it huge? So I'll just show you what exactly the size, if we want to compare this size with. So you might have seen this Eiffel Tower. So the Eiffel Tower dimension is around 324 meters. And the one which we are discussing about, Heliod X 12 megawatt, it is 260 meters. That's such a huge structure. And how much carbon emission we are saving from this? So it is around 52,000 metric tons of CO2, which is equivalent of the emission generated by 11,000 vehicles in 1 year. So that is something which is beautiful. because we are moving towards a better and greener world. Now coming to this, just to tell you like how much energy it generates. A single spin, a single rotation of G Halliard X 13 megawatt could power UK household for more than 2 days. So that's such a powerful machine it is. And we cannot install everywhere. We cannot put wind turbines wherever we want. No, we are having many constraints about the lens, about the air quality, about the meteorology, and even because we are onshore and offshore both, so oceanographies also play an important role in installing the wind turbines. And understand the model, prediction, and forecast the atmosphere and its impact on the wind energy system to develop a renewable energy system that dance with the wind. So this is just about a small introduction about the wind turbines. And now I'll focus solely on one thing, that is our rotor, because rotor is motor, as it is responsible about, it is the major thing which is responsible to generate electricity. And how we generate electricity is when the kinetic energy of the wind hits the blade, it rotates and it converts that energy into mechanical energy, and that energy we use to generate the electricity. So rotor, the rotor blade alone represent around 15 to 20% of the investment in the wind turbine. The most direct way to exert any influence on the cost of wind energy by increasing the rotor performance and thus the annual energy production of the wind turbine. An increase of 4 to 5% in annual energy production over the normal span of the wind life of 20 years. So generally it is 20 years. It can be more than 20 years to 25 years, depend upon the blades and the agreement what we are having with the wind turbine farm owners. So the most important thing here we are discussing about the blades. So the blade with the maximum performance secure the long-term investment. So till now, any questions or queries?
I have small doubt now.
Yeah, please.
In rotor part, which type of motors are using? Means machine, means induction. Yes, ma'am.
So it's a generator. I'm not having, actually, I'm a mechanical person, but I should have this information. I will get back to you this one, Mr. Ganesh.
Okay, ma'am.
I will get back to you about the generators, what we are using. Seriously don't have this is, but I can show you that this is produce 60 cycles AC electricity within the turbine. That's information what I'm having down. But please post the question. I will answer those questions later, or I'll get back to this with Arun and he will reply back to you. Would be fine?
Yes, ma'am.
Thank you. So here, so just to tell you about the blade design, what we consider in the blade design here. So here you can see the blade design, it's not solely aerodynamics. It is structural plus aerodynamics and a combination of both. Then it is about something about noise and tip losses. So you might have heard about that people, not in India, but in European countries keep on complaining about that this wind turbine is creating a headache to them. It is a noisy and all those things. Yes, there are some advantages of, there are many advantages of wind turbine and there are few disadvantages too. So we have to be very mindful when we are installing the wind turbines. So the best part about the wind turbines, I can say that it is coming from the source of energy is the wind, which is absolutely free, correct? And it is clean energy. We are not at all burning. We are not creating any CO2. And the best, again, another part is it is for long last till 20 years. So which is again give you an added advantage on that part. Now coming to the structural part here. So noise we can control by designing a proper tip and the losses. Then especially the starting parts, starting 20% or 30% of the blade is solely depend upon the structural point of view. Then aerodynamics come into the picture. And especially the tip part is solely drive with your aerodynamic structure. So this is what I can say. It's not only aerodynamics, it's about the requirement from the customer also. It's like what kind of frequency they want, what should be the mass, so that it will synchronize well with the other equipments in the blade turbine. So as our topic is solely we discussed about is about the blade structure. So I'll show you the few terminologies what we use in the industry. So if you see this particular blade, it is having a root section. Then this section, my cursor is visible to all.
Yes, it's visible.
Yes, ma'am. Yes.
Okay, thanks. So then there's a root section. Then there is a max chord section. Max chord section is the section on the blade which is having a high maximum width. So before that, we have a slight transition region. So blade root is a circular section. Then you can see it is taking an arrow profile here. I can say blade is a combination of a many arrow profile, and we're just joining those sections. So you can see there's one arrow profile here, there's one arrow profile here, and the tip section. So we divide in a terminology, we want to divide it as a root, max chord, mid section, and tip section. And there's a small section called transition section where we are transiting from the circular section to the arrow profile section. Then there is something which is leading side. We call this as a leading edge. Then it is a trailing edge. And then there we have spark caps. And we have webs also in between the structure called shear webs. Now coming to this is suction side and another is a pressure side. I'll show you more detail about it. So blades are designed, previously they designed using metals also, but nowadays all the wind turbines are using composites material. So what the composite material is, I will tell you later. But before, I'll just tell you how the sections are there. So we produce the blade into two major parts, which is upwind side and downwind side, two sections, suction side or pressure side. And then we join these two using adhesive on both the side, leading side and trailing side. So you can see these leading side, leading edge and trailing edge, and here we have adhesive. So it is adhesive here and here, and this is like root look like. And if you see this patches like what I have made, these are the tri-X. This is a composite material which is in 3 direction. That is why we call it tri-X. And here we have composite material in bi-X, which is in -45 and +45. That's why we call it bi-X. And we have UD, which is unidirectional, and it will start from the root till and in a single direction of 0 degree. So we call it as a UD ply. So these are the fiber orientation what I showed. And this fiber we mix with the matrix and it will become a composite material. And the property of the composite material is way higher than the steel or any other ferrous material. And the added advantage here is the weight is even 75% or like 75% of the steel. So we are, by using composite material, what we are doing here is we are just tailoring the blade depend upon the strength. So wherever we want strength, we use those kind of fiber materials, either it is UD or bi-X, and this will save a lots of weight for us. So as we know that blade should be lighter and lighter to generate more electricity, and this is possible only after using the composite structure. So composite structures, because sometimes we need some more strength, so we insert core. Core is a foam kind of structure which we insert between the fibers to attain maximum thickness or required thickness in those sections. Now here you can see these are the shear webs. So I showed you that between these section side and pressure side, we have some webs to strengthen the structure and prevent it from buckling and torsion. So how exactly the loads on the blade goes, if you see that the blade's hub, and it is like it is when air is flowing through it, and air is not like always smooth. It may have some turbulence, it may have some directions. So you can see this blade, once the blade hit by the wind, you can see that it will start rotating. Okay, and you can see on the top a small figure what we evaluated that, because wind can be in any direction. So we are just considering 12 bins, 12 different winds, assuming that it will be in flap-wise or edge-wise direction, and using the equivalent loads from there. And loads are based on the size specific, and it will be vary from the site. If we have suppose some in hilly areas, loads will be different. Ocean, it will be different, because air velocity, air turbulence will be different in different directions and different meteorology. So if you see you might have observed that this wind blade, whatever we are having here, it is not a straight. It is slightly bent. And why we need this bend? Because if this pre-bend is not present in the blade, it will hit the tower, and which will destroy the blade. So to consider that in the design, we are pre-bending the blade. Now I'll just want to show you, I told you about the composite material. So the composite materials is the first image. You can see it is unidirectional, and this is 90-degree of that, and this is a combination of both +45 and -45. These all are the composite materials. These are not standard isotropic metals what we are using here, and that make the design more complex, because here our failure modes are altogether different, behaviors are altogether different. So here you can see that, for example, if this is the braid section, and if I want to show you what exactly here in this block, so we have a foam in between covered with these kind of fiber matrix, fibers over that. It's a kind of a cloth, if I can see. You might have know about the composite materials, but composite material is similar to the clothes, woven in particular directions, depend upon the requirement. Either it is on 45, 0, or 90. So here, if you see that, as I showed you on the top, this particular zone will have a core materials and sandwiched with the fibers. So here you can see this 0-degree, then minus the 45, -45, and the core material, which is a foam or balsa. Balsa is a special kind of wood which is very light in material, and the same thing we are using in aircrafts also. So then -45 and 45, then and every material have their own properties. It is stronger in one direction, in other direction it may not be. So that is why we say that we tailored the blades based on our requirement. For example, if we are using the biax material, it is good in along the length. It is stronger in the shear. A biax material is stronger in shear, but UD is not. UD, unidirectional material, is stronger along the length. So we have to understand where we are putting it. So if we want the strength along the length, we have to put UD, unidirectional fiber. But if we want a strength along the shear direction, then we have to have the biax material with us. And the fibers, whatever we are using, it can be a glass fiber or carbon fiber. correct? So glass fiber is cheap in material, is a less costly material compared to the carbon fiber. That's why most of the industries are using uh, glass fiber, and so that they'll be more competitive in the market. However, few plates we use carbon fiber also, depend upon the requirements. Yes. So coming to the manufacturing part of it, so how exactly, like it's very fascinating to see things in production. And when we are designing things, because it is there on the system, but until unless you don't have experience about the blade manufacturing, it is kind of incomplete thing. So just wanted to show a few things here about the blade manufacturing. So we have one mold, and over the mold, first we apply the gel coat here. Gel coat is some kind of a small material which is you apply, and it is easy to remove the entire ply patches from there. So then we'll start laying up those fibers, either depend upon the requirements. Is it UD, BIX, and then all. After that, up, placing all the fibers, all the layup, then we place core wherever required. Once all the placements of the plies and cores are done, then we start infusing the resin in it. And first we create vacuum, then we infuse the resins. Once resins is done, then it will become a strong material, stronger than steel, I can say. Then we add those webs here. Once that is done, we do the similar thing on the upwind and downwind side, both the shells. Then we join both the shells, apply adhesive and close it. Once everything done, then we open it and demold it, and the entire blade will come out. So this is a small kind of introduction about how exactly blade is manufactured in the plants. Uh, okay, as we're talking about blades, we should understand what kind of failure modes blade will go. And as you see this images, if we have any failure in the production, we'll recover it. We can repair it in the production plant. But if any failure mode happen in the actual field, this is how our superheroes from our industries, our wind industries, go and repair exactly on the blade. So just to show you about the few buckling modes, what we can see here in our blade is buckling. So buckling is something similar to, you might have seen the hoardings. And if hoardings are like from some years or more than a few months, then because of air pressure, the bump creates on those hoardings. You might have observed it. If not, please have a look whenever you are traveling. So it is not a flat area. It is a bumpy structure which created on those hoardings, big hoardings. So similar thing, as because we want to have a blade as lighter as light possible. So we are having this blade here, and because of the loads, this kind of bumpy structure can create on a blade. So I can say the bending of the blade due to aerodynamic forces and reduced buckling capacity of the blade in the mid-span and mid-span towards the tip create this premises of failure. How to address this kind of failure? So these kind of failures we address by adding more layers on that and adding the core thickness. And when we are in manufacturing, we can see that because we are using different materials, we are using coal, we are using UDs, we are using different fibers and then adhesives. So there's a possibility that those things may not bond properly. So there can be a detachment of the skin from the core. Skin means those UD layers, those layups with the core. So I call these as a skin face sheets and the middle material as a core. And the possibility during the manufacturing, if the infusion is not proper, then this kind of debonding happens. How to address these kind of debondings is we have to be very careful about the infusion locations where we are infusing those. So you can see these are the infusion locations where the resin is going, the matrix is going, which is joining those fibers together. So we have to be very mindful about the locations and whether the resin is flowing properly or not. So this way we can address the skin debonding. Now coming to this, there are few other, because there's so many joints in the blade, so there may be a possibility of the cracks which can come on the zone. So one of the thing is, you can see this is a leading edge. I showed you the leading edge here. Like you can see, this is blade, this is the leading edge, and this is the trailing edge part. As we know that we bond these two layers, bond these two shells together, and we use adhesive to join this, there may be a possibility that these adhesive can fail and this can generate the crack here. Okay. And not only on the leading side, trailing side, and the main laminate where we are having the webs. Okay. Where we have a web. So this can be a possible locations of the crack and crack propagations. Apart from that, there is something called bending which can happen, and which, because it is aerodynamic loads and it is keep on going in every direction, like it is compression, tension, and which is causing the further, uh, because of these loads, you can see the strains which generates and it deform, and it can lead the blade failure. So apart from that, there are twists also which is coming, and which will cause the shear distortion in the blade. So I think I missed the chat, some questions or something. Okay, I think I'm just quickly checking. Please let me know if any questions are there in between about the design of the blades and all. Okay, sure. So now coming back to the shear distortion. So you know that this is the force is what is applying is aerodynamic, and which can twist your blade too. So we have to be very mindful while designing this blade. What all things we are considering, what all kind of fiber skins we are using in the blade. And we have to understand that it can be aerodynamic loads, the gravity which is also acting, and the combination of both can give a twist in the blade. So I can say the resultant load coming from the combination of edgewise load and aerodynamic force lead to a critical cross-section shear torsion bond line damage. So what bond line means here is, wherever we are using adhesive, we call this as a bond lines. Okay. Then there is something called, because it can failure from all these joints, all these web joints you can see here. Correct. So these kind of failure modes can be exerted from here. So this also we have to be very mindful while designing. Just give you a few more. So how we are designing these things better, because we know that reducing cost of energy is very important. And if we are having a reduced cost of energy, then we are in the market. And if we are able to compare with the other non-renewable source, and if a cost of electricity what we are generating is lesser than the traditional methods, then yes, people will go towards the renewable energy sources, which is better for our earth, and it is good for sustainable future too. Coming to the design, material, and process, just to give you a few sample things. So what the most important thing uh, and the challenging thing here to meet the customers of today. So we have to be the size of rotor, because the size of rotor is directly proportional to the your AEP, annual energy production. So if we are having longer and longer blade designs, rotor design, blade design, then it will give more and more, what do you say, it will generate more and more energy. As I told you in the initial, that halyard, which is 107 meter blade size, it can give a single spin of that can give around 2 days electricity for a UK household. And just imagine if we are increasing, I will just want you to go back to see this presentation again, because that will give you a beautiful reason why we are going towards the higher rotor size. So you can see the 7.7 meters, and it was just in a, so it is just, you can see number of households supplied in a year. So it was just 55 house. When we increased, we are in a single year. It is possible to, I think there's some question, sorry. So is it possible to prevent a kind of soft damage, or just design phase try to avoid them, but they will always appear? Could you please elaborate your question more, just to have a better understanding? Alicia?
Yeah, you can unmute also.
Yeah, please unmute and ask, because it will be good if we have interactive sessions. Okay, then I think, hope you are unmuting yourself to answer to just elaborate this. If not, based on that, I'll try to understand the question. Is it possible to prevent these kind of, okay, these kind of damages? Okay, perfect, understood. Oh, I thought it's as SOF, fine. Or just, I prefer to write, okay, no problem. Or just in design phase. Yes, so the damages, whatever we are having here is, these are practical, okay? And we have to be take care these in design phase itself, because we are not designing this blade only for few years. We are designing it for 20 years. So either buckling, so it is not only the design phase. Sometimes we have we use CAE to evaluate the design, and there is a certification body also which will certify your blade whether it is as per all the norms, and we should not see any kind of damage for next 20 years. It should sustain that. Even after that, there are few damages which can be occur. I agree on that part, which can be taken care in the later stage during the repairs and all. And damages like buckling, bondings, and all these things, even they should take care in the design phase. Even if there is some kind of miss, there is a testing phase which is also there. So in the testing phase, we give it for the fatigue test and static test, which will kind of prevent or showcase that we are 100% secure about the design. We are 100% sure that whatever we are designing, it will go long last. I hope that answers your question. Yeah, thank you. So coming back, please ask questions. It will be good. Thank you. So it will be good to understand, because the thing is, if you have to understand how the blade actually works, then you understand the importance of it. And ultimately, it is good for our Mother Earth, I can say, because we are moving towards something which is not good for our future, but our futures too. So we have to come for the solutions which is important for a sustainable greener world. So here, just to show you that now in a year, if you see this Haliadex can give the electricity to 16,000 homes. And that is not the best part. The best part is the how much CO2 we are mitigating. We are mitigating 41,120 tons of CO2. So it is always better to move to some alternates where we can reduce the CO2 emission. And as the blade size is increasing, that will help to remove tons of CO2 from our atmosphere, which will generate using the non-renewable like coal, petroleum, and other things. So you can see that like we are achieving LM as a GE business. It is achieving their milestones for the greener world by increasing the size of their rotors. From the very small of 7.7 to 23.5, then 34, then 61, and 73.5, then 88.4, and now 107. And future may expect something big and bigger and biggest from Ellen. So please ask questions if anything there. And then coming to this failure modes, I have covered these failure modes here. So the thing is, the rotor size, as I told, and you understand that what is the critical impact of the rotor in the annual energy production. So bigger the blades, better the annual energy production. Again, the modularity for flexibility. So we can use one turbine blade to another turbine and something similar to that. And then there is something called, we have add-ons or aeroprofile designs. So it is something more rigorous work where we can add some add-ons, small structure, which will enhance the AEP. Okay, or we can call it the boosting the AEP by some clever designs and all. Then definitely about the materials. So now we have to, so we know that the traditional materials like metals and other will not help us in this kind of designs, because we want a lighter blade, we want a stronger blade, and something which will last long for 20 years. So the standard materials will not help us. We want some advanced materials like glass fiber. So currently in LM, you use a glass fiber polyester combination and the technology where glass fiber is your fiber material and polyester is a matrix. Now we are coming up with some more advanced things called carbon hybrids. And there is something called low strain gel coats, which is important from the cost perspective and for the lighter blades too. Now coming to the process. So we know that we can save money, cost, we can save cost in many stages. So the blade manufacturers, we always strive for perfection. We don't want that the errors or repairs. Okay, we want a design should be perfect. What we are manufacturing should be almost have no loops, where it will go to again design phase and then again a design phase, then manufacturing, then repair and all. So we don't want, and we don't believe on this strategy. We want a perfection in one shot. But as we know that technologies are increasing, things are there are maybe chances of repairs and all, but we try to close this loop as close as possible. We use the lean manufacturing methods. We are the best in the market on this. Then we are quality program leaders with the proven track records, which will help us to attain in first time right all the time. And then we are having a match blades and industrialization, and we have experienced more than like almost 2.5 lakh blades till now. So that is kind of an added advantage what we are having compared to any other competitor in the market. So reducing cost of energy through efficiency and scaling. So as I told that we are very strong design drivers with us. We are many experienced people who know blade in and out from everywhere. But even after that, if there is any single miss, that can be taken care by our proven reliability, means our blade testing. So we test our blade to extreme to ensure reliability throughout their lifetime. So we have a test, uh, we have a test plants where we give this blade under testing of fatigue and static, so that we are ensured that our design is robust. So as we know that we have proven records for this blades and technologies. So once we develop our blade, we are another way is like, once our blade is manufactured in the manufacturing plants, it is important to ship from one place to another, because we cannot handle the blade from any location across the blade. It should be handled only on the few fixed location which we designed for. So that is how our transportation systems comes into picture. Because you know that we are designing this blade for the lightest, how much light we can create, what is the least mass which we can put in the blade to have more and more AEP. So we'll not make our blade stronger everywhere. It should be based on the load what it will go. As transportation is another load, so we strong our blade, we strengthen our blade, the location where it will be transported. Our blade is transported by roads, you might have seen, by ships. You can see in one of the image here, it is transporting by ship, and even by air also. So when we are transporting our blade from one location to another location, we have to be very careful about it, because the equipments what we are having, it's very specific to handle the blade, to move it from one place to another. Okay, so this is how, like, because you know that even after that there may be some kind of miss by any chance, or some storm, or some particular uh, atmospheric condition or environmental condition which may be there. So how we take care about this is by by our inspection system, by our maintenance system, so that we'll have a long-term investment. Whatever we have, it is a secure long-term investment. So Element Power provide a service solution to back up our product, and we can provide a full spectrum of maintenance, global footprint, and region workshop to ensure this one. So coming back to here, do you have any kind of questions here till now before moving to the next session, next topic? It would be good if we make a session interactive, because these blades are something, it's not only on land, it is on your oceans also. And when we're installing on the land, it's a different things which is coming to the picture. When we are having in oceans, it is a different situations. You may have a question like, what is the disadvantage of these? Because we are seeing all the advantages of this. Do you think that it can have any disadvantage, please?
Like salt corrosions.
Salt corrosion, please elaborate a bit.
Yeah, in the blades and in the where we have fixed that, like, so if you are more and more salt corrosions, sodium hydroxide corrosion will be there.
Yeah,
So
yeah.
to prevent that, what kind of materials you are coated on the blades?
Yes, yes. So you're right. So based upon, if I'll specifically tell you about the blades, the material what we are using in the blades and the gel coat and the paint what we are using, it is that salt corrosion will not impact at all. Will not impact or not at all. So even if it is on the land or water, we have special coatings which will prevent, but especially on the blades, because we are not using any metals on that. We are using composite materials. So which
Okay.
is one of the important thing about the blade design.
Cyclones
But
are
then
coming.
bottom parts where it is stand.
Yeah. So those are painted properly with these the part which is inserted. So we call them stages. So these are the which is already taken care by the paints and all, and the strong materials. So these are sometimes made from cement, sometimes made from the metals with the painted where we have a non-corrosive paints over it, which will be
Is
long
there
in
any
years.
is there any continuous monitoring or
Yes.
maintenance of 6 months, 3 months,
Yes.
something like that?
Yes. So depend upon the location, depend upon the oceanology. For example, if we're talking about the oceans, uh, we are having the maintenance plans, we are having the repair plans. So whatever, if suppose, and we have a data also. So based on that, we go for a timely periodic maintenance and periodic inspections, which will take care that the strategy of 20 years should hold good on these structures.
Okay, fine. Yeah.
Yeah.
Next.
So another thing, have you ever think what happened after 20 years of these blade, huge structures of 100 meters of blade? What will happen after this? And as you might have heard about these winds, many of you might have seen these wind turbines, and you might have heard this sound also, zwing sounds. Has anybody experienced these kind of things? Just give me yes or no, that's fine.
Yes, it's located near to Nagarkoil and all in Tamil
Uh-huh.
Nadu. Near to
Perfect.
Nagarkoil, in the roads, you'll get that
Yes,
sounds like.
the swing sound. So isn't a sound that irritating? Sometime, if people are
Sometimes,
staying there,
not
yeah,
exact, not all,
correct?
not all
Not
times,
always.
sometimes.
Yeah. So if you are staying near to that location, then it is problematic for you. That is why we have to have a clear boundaries where we should install those, where we should not. And do the similar thing happen to the animals or the, I can say the sea, the fishes and other things? Check it out. Check it out, because if it is problematic for humans, is it a problematic for the sea creatures also? But there are some. So these are the installed. We consider those kind of things when we are installing this. We are considering that we are not in the zone where the fishes, the critical or the creatures, the what you call the water animals are not getting affected. Apart from that, the best part about the installation from the GE, we are taking care of the coral reefs also. We are breeding the coral reef so that we can maintain the ocean properly there. Because you might have heard that coral reefs are reducing. That is hampering the water lives too, oceans, seas, and all. So when we are having the bottom part of that, which is underwater, the breeding of coral reefs are going on, which is supporting the oceans and the creatures in the oceans. This is just a point which I have to highlight. And any other disadvantage which you can see here, because you are the yeah,
Cyclones occurred in Seaman.
and that,
Entire.
yes,
That
it
is
can
also
hamper.
one of the disadvantage.
Yes, but we design for that also. Our design include certain the speed. And what happened during the cyclone? The blade stops actually. There's a system in the blade. It will not work when cyclone or some high gust loads act on the blade. It will stop rotating so that impact of that will be minimized. And if it is very critical cyclone, yes, that will hamper, because it will hamper any structure. But we consider those high gust loads also when we are designing when we are designing our blades. And if you see these blades, the orientation of rotation, I can show you on this part how we control and reduce the effect of that too. That is taken care here. Yes. So you can see Apart from the rotation along this axis, our blades can rotate in this direction too, so that we can extract maximum energy from the wind. We don't know wind can come in any direction. It can come in this direction, can come. So based on the trend, based on the studies, we can rotate this wind so that blade can rotate in any direction based on the requirement, so that we can extract. That is the technologies we are having. Okay. It can rotate in this direction and this direction, apart from this, the the standard rotation what we have. Okay. So any other question, any other concerns, like, because the thing is, when we are in the market, we think in different way. When we are not in that market, we think in a different way. So I want you to think about it, think about these structures, think about how we can best extract the energies, because this is the future, definitely. And if you see the growth, this is the growth what we are having. And not only this way, but you can see how exactly it is growing. And it will grow. And I'm sure even the pandemic also, the wind, it slowed down. I agree. The installation of wind capacity slowed down because of the resources, but the trend is still increasing. If things are increasing, why it is increasing? The target is 80 megawatt in next few years. So if anyone, please, questions, and we can have an open discussion on these topics, if not questions, how exactly thing works, why these kind of structures are like this, why not. So I'm a mechanical person. Any mechanical question about the design, about the functioning, I'm most welcome. I know most of them are like from electrical background, so I may not able to answer those electrical questions, but yes, we can discuss about the general trends and the behavior of the wind blade.
I have one more doubt, ma'am.
Yes,
In our
please.
area is a developing country, ma'am. Means
Yeah.
all the parts should be available in India, ma'am, or still importing to other countries? Means the
Beautiful.
designing of the parts. That question, ma'am. My question is.
So before that, could you also Mr. Ganesh, correct?
Yes, ma'am.
Yeah, perfect. Beautiful question. And like the make in India thing, correct? I think you are thinking in that direction, if I'm not wrong.
Yes, ma'am. Yes, ma'am.
Perfect. So you know that just to show you, this is the highlight where we are in India. So all the blade designs, whatever we are designed for India, we are producing in India itself. So we have in Baroda, Bangalore, we have another plant in Pune. Like, so the production plants, two major plants, which is in Bangalore and in Vadodara, Gujarat. So these things are taken care when we are considering make in India things. So we are designing our blade, we are manufacturing our blade within ourselves. So if you have an opportunity, anyone, please go and see the production plants where this blade, turbines, everything, even generators also, it is made in India. That's what I know. Everything, towers. So if it's installation, not only this, even for China market, India is producing blades. Even for France market, India is producing blade. Then again, the transportation cost and everything comes into picture. So that is why we have many locations based on the cost and other things. So India is having an advantage where, because we have uh, our labor is not that costly. Production cost is also comparatively very low compared to other countries. So that is advantage India is having. And even many other, not only G, but many wants to produce blades in India because of the low cost. Hope that answered question, Ganesh.
Yes, ma'am. Thank you, ma'am.
Yeah, thanks. Any other questions, please ask, because this is something, it's not about, because the data you may get it from online, but it is all about the discussion what we should have with the person who is in the industry and you are from the background what you are having. Because it is one of the way which we connect people, correct? So please feel free to ask a question. I'm proceeding further from next slides and all. So please stop and ask questions, discuss about the blades, discuss about any crazy question, and all questions are good. Okay, now coming to the powering a sustainable planet, and what is the key market drivers? And the key market drivers, whatever we are here, is the answer is the wind. Because you can see when we have wind farms, we are not losing land, we are not creating CO2, we are not doing anything. People can grow their crops in that. And if it is a arid region where it's a desert or something, if wind quality is good, we can have a wind turbines there also. We have a wind turbines in mountains also. So we are not wasting the lands when we are going with the wind energy. So it is a beautiful solution to match up the energy requirement of our future. Correct? And as we are very much robust about our design, which we are doing it, and considering all the failure modes, which will give a life of 20 years, so that is a win-win situation for us and the wind and the Mother Earth too. Okay. So again, coming to the things here. So the long-term drivers for the wind energy development, increasing energy demands from the population growth and emerging economies. As you know that India is emerging economy, and for any economy which is emerging or developed or developing or even underdeveloped, they need energy, they need electricity to be in the market for their growth of the country. And wind energy is one of the solution for that. Climate change. And you know that every year, like climate change mitigation, every year there's a increment in the temperature of from 1.5 to 2 degrees Celsius. You know, this rise in temperature is there. And because of that, like if we are able to do something where we can control or where we can support to suppress this or mitigate the carbon emissions, we are returning something to our Mother Earth. Okay, so by reducing the carbon emission to stay within the universally agreed upon 1.5 to 2 degrees Celsius, uh, which is rising, if we can suppress that, that is something good. We are contributing it. Energy security. So we know that fossil fuel, it will not long last. Okay, and fossil fuel, what they'll do, it is something like some particular countries have power, they have petrol, they have something, so the market cost and everything is driven by them. And what if those ends? Okay, what if there is a supply or demand don't match, then there's a fluctuation in the prices. And what if we exhaust all the fossil fuels? So we should think about some other alternatives, we should think about some other uh, energy mode which is give us sustainable energy for long life. Correct? Then coming up to the energy price stability by leveraging renewable production in the energy mix to hedge prices. So as I told that the price, as you know, that petrol is more than 100 now in India. So these are something which is very much dependent on the fuel supply and demand scenarios. Correct? So how we can mitigate these kind of instability in the cost of energy, correct? If it's a coal or any other petroleum products. But if we have something which is sustainable for a long time, and the wind energy, which will be there now, it was there in past, and in future it will be there, correct? So we don't have that risk of price stability, instability in the market. Correct? So safety, health, and environment concerns. So you know that the traditional energy sources, whatever we are having, they have hazardous waste. Okay, the water footprints, the lakes, and everything is getting contaminated because of those things, and it is impacting on our Earth and the system, what we are having on Earth. So water is getting contaminated, air is getting contaminated, and that is how the things are polluting even our food chain too. Correct? So, so the thing
Yeah.
is, yeah, any question?
Yes, some questions like coming to the cost point of view.
Yes, please.
Parmesh is asking what is the overall cost for each blades?
Good question. Good question. So Parmesh, so depend upon the size of the blade and technology what we are having. Correct. The thing is, as you know that the carbon fibers or the fibers what we are using, these are the costly material compared to metals. But how we can compensate this is by doing the design smartly. We are not putting as much as material we want. We smartly tailor where we want material. So based on those things, based on the blade size, based on the technology involved in it, if I say around 70-meter blade, so how much you expect? Just okay, just a question, just to understand where you are in thinking. So Parmesh, where do you think what may be the cost of around 70-meter blade, and what will be the weight of that? Any guesses? Any wrong guesses would be fine. You can type it. Anyone can type. Okay, I think people are not interested to have this one friendly communication where we
Means,
can.
ma'am, I think 10K to 20K, ma'am. Yes, depending on size and length.
10,000 rupees per blade.
Yes, ma'am.
Parmesh. Okay, so Parmesh, if it is 10,000, then I think all of us might have started having a wind farm with us, correct? Yeah, at least a single wind turbine we might have afford at our home. So okay, 1.5 crores. Okay, that's a two extreme things, and I saw it's some 5 lakhs also. So for example, 70 ton, which is 10 lakhs per blade. Yeah, yeah. More, I would like to see more answers, because it will give you some idea because how exactly we are standing in market. So my question is around 70 meters blade, what may be the cost of a single blade with the basic technologies? And any guesses on the mass size, where it can go? How long, means what is the weight? 20 lakhs for 70 meters. Yes, looks sensible, more sensible. Um, so and weight wise, how much kgs or tons it may be? Any wild guesses? Every answer is right, please, because we are new and many things we learned after coming to the industry also. 5 tons, okay, okay. We'll wait for one or two replies, then go ahead, or shall I answer the question? Okay, I think most of them are like the right, and uh, they are understanding the complex. The thing is, why these blades are costly is the reason here is I can see the major reason is the complex materials what we are using. Okay, and the complex material is none other than the composite structures. Okay, composite structure, the fibers, because these are fibers, and you might have seen uh, I think you might have seen the composite material somewhere. Anyone saw composite materials? Played in short 20 years. Yes, yes. Yeah, that is another adding point. Yeah, because of the life 20 years. Yes, you're right. So anyone know what is composite material actually? Because I told you many things about the
Yeah.
composite, but have you ever seen composite material? How exactly
Yeah.
it will look? Yeah. So can you give me an
It's like
example where you saw?
Composition of different metal
Um,
oxides and polymers.
Metal oxides, okay, okay. You might have seen the green color shed in many of the homes, which have some fiber structure. You might have seen. Anyone saw that one? The green color shed on the roof.
Yeah.
Yeah, you might have seen that. So these are very basic composite example. Even your bumper of your car, even body of your two-wheeler, these are all are made up of with a composite, very basic composite material, which is not having the structure. Previously, they used to have for the metals, but now all these things are replaced by composites because of their light in weight and the cost.
And Teflon also one of the material composite material. Teflon.
Yeah, Teflon. Okay, yeah, yes. So I just wanted to know the real life examples, like where you saw, maybe if you see the accident of a two-wheeler or somewhere. No, now these are something fibrous things coming out. Previously it was metal, but now these are composites. If not, please observe those things, because that is something like, yeah, space structures. These are composite materials. Yes, these are composite materials. Now, so this is what I want to show you, that like someone told about the Teflon. So these are the coats what we are having, where we combine it with the so that is nothing, Teflon is nothing but your polytetra fluorescent ethylene, if I'm not wrong, and then it is combined with the fibers, and with the fiber, which is a structural responsible for the strength, and the matrix which will join. Okay, so it is something like which will strengthen your structure. So you can please see how exactly in your scooters, in your cars, and the sheds, these are the composite materials. So coming back to the topic, and the topic, what is the cost of the blade? Cost of the 70-meter blade is average of 50 lakh rupees, one blade, and it will weighing you around 16 tons. Good. Something interested? Correct?
Yeah.
Yeah.
Fine.
Yes. So that's
Like,
what, just wanted to give you the feeling of the product. See, everyone, you can Google it things, but when you are getting opportunity where we can interact with each other, it's a good thing where we can see something which is will not easily see in Google, and which we can make the session more interactive. Yep.
some
So
some more questions, like, is there any possibilities of wind blades with the solar panels,
yeah,
like
yeah,
hybrid structure possibilities are there?
yeah. People are doing that. So in the bottom, they are having a solar panels, and the top they are having this one, wind. So that's a combination of what? Or a question is something where we have a blade with the solar
Yeah,
panels.
blade
Huh?
with solar panels. Yeah.
It's a very good question, and a very good approach too. But the thing is, the main purpose of blade is to make the blade lighter, and it should sustain for those kind of loads, what the gust loads. The tip speed is more than the speed of your Formula One racing car. Can you imagine the speed of the tip? Not the top, not the root side, the tip side. It's around 300 kilometers per hour. So to sustain that
Whatever
speed and load,
then whatever we are fixing it, that maybe might have lost from that location.
yeah, so that will reduce your speed, that will add weight on it. And the purpose, the extra. So ultimately it is all about the cost. So if we are able to design something where where return is more than what we are investing, then it is a good option. Otherwise, there are many options people can try, but what is sustainable, where we can get good business also. So currently, maybe in future, if we have some standard materials where we can implement both, but a very good idea to use both as a single and try it something good. Superb.
Coming to the point, like how it is to be connected with the grids and all, like grids and the latest technologies, smart grids, how it is to be connected, that one to one and all.
Yeah, so so what you can see it here. I may not answer the 100% question of yours, but you can see that these things. So we have a stations for every farm. What is farm is where we have some more than 10 wind energy, 10 wind turbine, or 20 or maybe 1,000 or 100. So everything will be connected together, and there will be a local power grid. And from that local power grid, there are two solutions. Either we can directly supply, and nowadays they are planning to have some cells which can store their energy, and we can utilize those source of energy.
Like the transformer kind of things before transmission to the
Yes,
grid.
yes.
Yeah, fine. Like that the monitoring out is to be
Yes.
possible on the remote locations. Is there
No.
any
Entire team will be
like,
there. Entire team will be there, which will handling, and there is a automation things which is going on there. And you know that we have many controllers and other things which will take care of those grids.
then coming to the connection of carbon fibers is sufficient? Like natural carbon fibers kind of thing is also added, right?
In the blade design?
Blade structure. Yeah, in the blade designs, the
Yes, so we have,
materials.
so as it is carbon fiber coming to the picture, so you might have seen the lightning effect also. I'll not connect, but yeah. So carbon fibers, we have the carbon fibers in the blade. So because you know that these blades are something which is sharp, and it is more prone to get the lightning also. Okay. So what exactly happened? We have this lightning protection system in the blade itself, which will
Yeah,
help us to
then
dissipate the energy to the ground instead of damaging the structure.
question out of curiosity, like along with the carbon fibers, why can't you use the waste plastics? Then
Yeah.
you will get the good structure, and that plastic waste also to be utilized, right?
Yeah, right, curiosity, and we are doing that. So you saw the foam, the core side. So those core side last year, I think 20,000 tons of, it should be in the design. Just give me a minute. I'll show you. And that is what actually I wanted to people to ask these kind of questions before when we are doing this. See, these core materials made of foam. And nowadays, what we are doing is we are recycling those plastic bottles to make the foam. Which
Then
is very,
we can get the materials as well, then
yeah.
recycling things also, like
Yes. That
this
is
is to
what
be
the
like
score is made up of nowadays. We call it as
uh,
RPET. That is a renewable PET. Okay.
okay,
Yeah.
fine.
Good.
Like if
So
you are having carbon fiber, then that will give the strength. Then
yes,
material, additional material, whatever the polymers you can add it, right?
yes. So we are using for foam as of now. Whatever foam we are using, for that we are using that these things. Okay, perfect. I think I'll answer your question.
Yeah, yes, ma'am, yes.
Perfect. Okay, then
Participants, any other questions?
yes,
Just
I think there
you
are few things. Is there any significance
few
of number
questions.
of blades? Yes, number of. So you see, like one single blade, the halyard, which I shared you initially, 30 megawatt, that will give you, that will give 2 days of electricity for a single household. Just imagine we have 10, 20, and 30. So it's a multiple of that. So yes, it's important, but it's also important to have the arrangement properly so that it will not distract the air from one blade to other, because you know that there is distraction because it is ultimately the flow of air. So we have to arrange those blades, to arrange those wind turbines in such a way that it should not distract. So for that also we have proper study. We cannot randomly arrange those. We should see the direction of the wind and then install those. And definitely, yes, number of blades are useful for us. And that is why we want more and more blades to have more and more energy. Next question about the soil. Yes, soil is important. The reason is you might have seen in few days ago, the turbine entire the tower came out from the center. So we have to understand the soil in such a not a soil, actually it's a platform. So whatever the platform what we are having, correct, it should be properly constructed so that it will not hamper the strength, because ultimately if you see the strength is the your root side, correct. So if your tower root is stronger enough, then it's not a problem. Next question is how to identify the wind energy potential. How do you identify wind energy potential zones? Okay, yeah, perfect. So yes, good question. Again, I'll show you here So you can see that what is the average speed? What is the instantaneous speed? That is two common factors which we use, correct? And it is again further depend upon the topology what we are having at the result. And yeah, you can see here that the arrangement what I showed you, correct? It cannot be one after one. It should be something where we are not disturbing the wind flow, so that all the wind turbines can get the proper speed. So if we see the average speed and if we zoom and see how exactly, so this is the thing. And the question, coming back to the question of Mr. Satyanarayan. So the potential zones is, again, we have to understand, we have to go through each and everything. So we have to understand what is the low jet stream level, what is the oceanology, meteorology there, what is the availability of or transportation, because if we want to ship bigger wind turbines, bigger wind blades, so we should have some proper routes where we can go and meet, where we can transport our blades. So wind speed is a major important, then your terrain is also important, then your what you call it, the like entire year how the scenario in that zone. So these are the few common factors which is important to understand the potential locations of wind
Yeah,
for
that's
wind
what like
farms.
for coming to the solar cells and all, we can identify this particular location all
Mhm,
good solar
mhm.
hotspots.
Yes,
Then
yes,
like that is the the
yes,
how you are measuring the zones, how you are
yes.
identifying the zones you are going to install and all.
Mhm. So,
Is
so
there any
similarly, yeah.
platform?
Similarly, we have a same study about about the about the wind, where we have to install the farms based on the wind energy, based on the climatic condition, based on the average and instantaneous winds.
Any other questions like? In the same related, Sarah has published on paper on how to identify the zones to look.
Yes, ma'am.
We
This
can
is
install that.
Satyanarayan, ma'am, sir. Sorry, sir, disturbance. This is Satyanarayan.
Go ahead, sir, go ahead. Go ahead.
I identified wind energy potential zones over India and the ocean,
Oh,
very suitable places. How many hours per wind turbines? Different wind turbines we have. Low turbines,
okay.
high turbines. Low
Uh-huh.
turbine 3.5 meter per second wind turbines. Where is the suitable locations all over India? We identified potential zones. I published paper in Spring and
Oh,
Nature.
superb, superb, superb. I'll definitely go through it, Mr.
Yeah,
Satyanarayan.
we have generated 40 years wind turbine data.
Superb.
Yes,
Uh-huh.
ma'am. Every hourly within 12-kilometer resolution data.
Oh, that's good data. Yes.
Yeah, yeah. The ocean to land to how much distance, how much far we have to suitable wind turbines will suitable to
Mhm.
potential identified. That zones also I have to put ma'am this paper. Uh,
Superb, superb.
Actually, you have to see that paper, ma'am.
Definitely, I will. Definitely, I will
Yes, sir.
see and I will share with my teammates also. It will be a
Yes,
good
ma'am.
information to check. Thank you so much,
Yes,
Mr.
ma'am. Yes,
Satyanarayan.
ma'am. Yes, ma'am. Okay, ma'am.
Yeah, great. So yes, coming back to my presentation, if no more questions, and are these wait more? Da, 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 da. Mr. Pamesh, yes,
Like,
this is
yeah,
ideal
one
wait
final
actually.
question, ma'am. Like, one final question.
Now,
Yes, please. Yes, please.
Like, the coming to the design in solar panels, we are having some tracking kind of things. So
Mm-hmm,
morning to
mm-hmm.
evening, we are tracking the things. The
Same
same way,
thing is there.
in the wind, like
We have
3 months this direction, and another 3 months. Is it the fixed one, or you are
no, no.
having the data on how it is to be rotated?
Yes. So you can see that we have sensors. Okay, based on the sensors, and we have some particular speed. For that particular speed, it should be in this direction so that we'll extract the maximum AEP. And that is why you can see here, here you can see we can rotate. We have a rotation along this tower also, and we have a rotation further along this blade also. So blade length axis, there is one rotation, and along the tower also we have rotation. So based on the sensor data, whatever we are extracting, because every hour data is important, every hour wind is important to generate electricity. So based on that, based on the sensor study, It is programmed that wind should rotate in that particular direction. Wind turbine should rotate, and wind blade should rotate in that particular direction to extract the maximum energy. So this diagram, you can see the rotation here and the tower rotation. So based on that data, because entire year we don't have the same kind of wind, same kind of speed. So based on that, it will change its direction and the rotation too.
Thank you, ma'am. Thank you.
Thank you.
I think.
Ma'am, I have
Yeah, go ahead.
one question, ma'am.
Yeah, please.
Ma'am,
Yeah, please.
here, after completion of the manufactured blades, ma'am, means total part is done. Any
Perfect.
kind of special mechanical test is taking place,
Yes.
ma'am?
Yes,
Before
we have.
installing the blades.
Yes, we have. So the most important thing here is the weight of the blade. Okay, once the blade is produced, correct? Because we are not using a standard materials like steel or something where we know that mass is same, correct? Here we are using carbon, we are using fiber materials, layups, correct? And the matrix materials, whatever the flow, the infusion we are doing, no? So that may be somewhere higher, somewhere lower. Okay, so what may cause that? Whatever we are designing, that weight should be in that range. We cannot say that we'll exactly make 16 ton. It can be 16 ton, 100 kg. It can be less than 15 or 20 kgs. Okay, so once that is done, then we evaluate first based on the weight. Okay, so if weight, because the balancing of all three blades is important, because there's a three blades in this, and if any one of the single blade is higher or lower, then it will cause a problem in the balancing of that. And if balance is not proper, it will impact on the other structural part like gears and other things, correct? So that is one of the important test of the blade mass. Then we have a visual inspection. Then we have ultra rays also, UV rays. We check that all the bond lines, everything is proper or not. Is there is any dry fiber? So dry fibers like where we see that we are doing infusion, and there possibility that that liquid material is not reached to that fiber, and we don't have that fiber matrix there, so it will weaken the structure and only fiber are there, so that we call it fiber rich. So then we have to inspect that, and we have to repair that section. We cut that, we maintain, and we repair, and we infuse the matrix material in that. So these, and apart from that, twisting also. So there are many tests actually which we do before installing it to the plant, or before releasing the blade from the plant to the production, the transportation also.
Thank you very much, ma'am.
Yeah, thank
Thank
you.
you. Yes, ma'am.
Okay, yes. So there are many things which is very deep, and very good that you people are asking questions, because that is only will give you better understanding of other things. So again, coming back to the safety, health, and environment concerns, so everyone know that those are not a better options. Whatever we are doing till now, there are many better options. And after then these wins, because we have a life of 20, there are more sustainable way to decompose these, sorry, not decompose, but handle these blades after the lifetime also. So people can go and check what happened after this, the blade over. So it should not be a scenario like how we are having plastics, correct? It's floating in our ocean. It should not be a scenario with these blades also. Correct? To think about that part also. So just go and check all these options, and please feel free to connect with me on LinkedIn, any kind of questions and all. Okay. And it is not only the production company which is responsible for the cleaner world. It is all of us. It is all of a single move, the selection of the things. Either we are going for market with a bag or the poly bag, or with a cotton bag, the material which we are selecting when we are buying for our clothes. So what ultimately I'm seeing is we have to be mindful in our selections. And it is because we are all are having a strong commitment. It is not about the organizations which are doing this good work of supporting greener world. It's all of us. So yeah, that's way I can close my presentation. Thank you so much for all your time, and take care. Any other question, please let me know. If not, if any other question, you can connect to Mr. Arun Mehta to post the questions. We can connect later also. And if any urgent question or any kind of curiosity, please connect with me on LinkedIn. I will happy to answer. Yeah. Thank you so much. Hope I answer all the questions. and session may be helpful for you. Thank you all.
Yes, ma'am. I think everyone got their answers and they are listen. It's fine.
Yeah, perfect.
I'm checking once any other questions. I think
Yeah, please.
we have answered all the questions which are in the chat box. We cover all the questions. Sir, Satyanarayana sir. Sir, Satyanarayana sir. Yeah, ma'am. So like,
Sir.
yes, sir.
Yes, sir. Tell me.
Can you conclude the session, sir, on behalf of department?
Yes, yes, ma'am. I thank you very much, ma'am. I think we will collaborate and in future, ma'am. You are given a very good lecture.
Thank you so much.
Very much, ma'am. Once again. Hi, ma'am.
Yeah, thank you so much. And I'll definitely go to that important article, and it will be really helpful. I think keep doing these kind of work. It is important.
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Thank you. Thank you all, and take care all. Stay safe.
Yeah.
I'll stop. Yeah.
Thank you, ma'am. Thank you so much.
Thank you. Thank you so much. Bye-bye.